So, hello everyone. Today I'm going to solve the question of linked list, which is middle of the linked list. Okay. So basically, we have given a linked list, and we have to return the node of the middle of the linked list. Okay. So let's understand first. So there are two cases, maybe a number of nodes, maybe even or maybe a odd. So in that scenario, uh, when number of node is odd. Okay, so we know the middle node is this. But when the number of node is even, then middle node is both. So in this situation, we have to return second node. You can see here, we have to return the second. Means we have to return the this node. Okay. So how we are going to solve this question? The first brute force approach is what we will do. We just find the length of that uh, list, right? So first we will take a pointer here and take a counter variable and count. So basically first time we have to start counter initialize the counter variable one with one, because first time it is at node one. So it will move here and it will move here and it will move here. Ultimately 1, 2, 3, 4, 5, 6. So there are basically six node. Sorry, there are total six node in this. So basically this is even. So when we divide 6 by 2, it will be 3. But our goal is we want node 4. We want node 4. So basically what we will do, when the number of node is even when we divide first, then add plus 1 to the result, and that node is our answer. Let's say this node. In this case, this is number of node is basically odd. So when we divide, when we divide, or instead of doing this, what we will do, uh, if number of node is 6, then add plus 1. It will be 7 divided by 3. It is okay. Yeah. So, yeah, the same thing. Okay. So here number of node is 5. So when we divide 5 by 2, it will give quotient 2. And then I have to add 1 plus 1. So in both cases, in both cases, you can say first we calculate the number of how many nodes in a list, count that node, and then divide by 2 the total number of node, and we add plus 1, and that node will be our middle of the middle node of the list. Okay. Okay, understood. So let's solve this question with this approach. Okay, so first what we will do, we will take a counter variable. Counter we will initialize first, because first time when we take a, because head is always pointing to the first variable, right? So what we will do, we create a list node for and assign the value of head. And now what we will do, while temp is not null, count plus plus, and temp is equal to temp arrow next. We first increase the count and move the pointer to the next one. Increase the count and till when we doing these things until we reach at the end. And after that, what we will do? We have count. Now we find the middle of the node. So what will be the middle node? Middle node, middle node is equals to what? Count divided by 2 plus 1. This is the our node. So now our goal is reach at the this part. Okay. So we have fourth node, right? So what we will do, we again take a counter variable, and now we have n is equals to, when we calculate n is equals to 4. So we take a counter variable 1 and initialize with 1. Okay, and then we move check if 1 is equals to 4. No, so move ahead and increase this counter variable by 1, so it will be 2. Now again check, 2 is equals to 4. No, we again uh, move ahead and increase the counter variable to 3. Then again we'll check, is counter is equals to middle node? No. So we and again improve, sorry, move ahead, and when we 4 is equals to or 4, we will break, and that node is our middle node. Okay. So in this case, what I will do, in let's say int I is equals to 1, and while what I will say, uh, we say while we have to take, we have actually we have to traverse again. So just we have to again assign the head value to the temp, and temp is not is equals to null. Now we will check if I is equals to middle, I is equals to middle. Yeah, when I is equals to middle, then return that temp. Otherwise, what we will do, increase I value by 1, as well as move the pointer to the next node. Okay, okay. So this is the, or you can say, when we reach here, we just break, because we have to return something. That's why I'm breaking here, and now we will return here same thing. Okay, so let's run it. It is working or not. One edge cases is also there, so let's check first. Oh, double L is there, and one more edge cases. Just see the constant. When number of node is 1, then that is a middle node. So that in that situation we check if head next is equals to null. In this situation we will return head from here, need not to go ahead. Okay, so let's run. It's working on that. Okay, so we move ahead. Okay, actually our head pointer is go one step ahead. Now it is okay, 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 okay. So basically what we will do here, will we keep 1, and yeah, it is okay. So what is happening here? Let's see. In this case, there are 5 nodes, right? There are 5 nodes. 1, 2, 3, 2, 3, 4, 5. Okay. 5 divided by 2 plus 1, that is 3. So this is our middle node. Okay. So now our first pointer is here, and we have initialized I value with 1. And now we are checking, is 3 is equals to 1. 3 is equals to 1. Then what I will do, not not it is not equal, so what I will do, just increase the value of I to 2, and move that pointer here. Now again check, I 2 is equals to 3, no, so move this pointer here, and it will be 3, and we will check yes, and we will break. So why it is okay. So now we have to Okay, okay, okay. Just do one thing. We have to go one move before that. So in this case, there are four nodes. Expected is 453. Okay, but how? Let's see. There are four nodes. There are four nodes, three nodes only. Okay. There are six. Then we have to remove this part. 456. Okay. And I am returning this. It's, it should be given right answer, but this time this is saying one move ahead. Okay, okay, okay. So basically, yeah, here we have to check for odd and even cases both. Because you can see here, you can see, you can observe here there is number of node is odd. So it move one step ahead. Okay. Here number is even, so it is okay. So when the number of node in a list is odd, then we will not add one, right? So here we will check if where is yes. Here we will check if count is divisible by 2, then what I will do? Here you can see. Then we have count is 2. Then we can increase means we have a number of if number of node we have even, then we increase, otherwise we will not increase. So yes, and otherwise else we just assign this part only, right? Right. And it's running. Still it is giving wrong answer. Why? Now both of the test cases failed. Let's see why it is giving wrong answer. Okay, it should give 3 4 5. Instead of it is giving 4 5. Okay, and oh, it is giving one extra. So what we will do here, middle is okay. Let's try them. Then we can observe why this is giving wrong answer. There are four nodes, right? So we are first here, and we have counter variable initially as 1, right? 1. So we first check temp is not equals to null. If that pointer is not null, then increase value and move pointer. So we will check. No. Uh, so what we will do here? Basically, we have checked count is not null, so it will become 2 here. Oh, so basically it is counted one more, one extra node. So when we can start counting from 0, then it should work. Still Still problem. Why this is happening? Let's see. Okay. So we have count initially 0. We have count initially 0. Now we will check temp is not null, so increase the count value. Now we come, we are at here. Now we will check if count is at temp. Sorry, temp is at null. No. So increase and move pointer move here. Now again check is temp at null. No, no. So just increase the count and move ahead. Now here it will check is count is null. No. So it will reach here and this time count will go here and now we check count is null. Yes, count is null. So the total number of node is 4. So this is even. So in even, when number of node is even, what we are doing here, when number of node is even, we are doing count by 2 that is 4 by 2 plus 1, right? 4 by 2 plus 1 that is 3, that is 3. So it is okay. When we have the even number of node, we have to remove the, we have to return the second one, right? Okay. And this test case is failing on, no, it is passed on even. Just check for odd. So yeah. So in this situation, our count will be 1, 2, 3, 4, 5, right? So when we divide, find the middle, then it will be 5 divided by 2 plus 1. That is, it will go 2 plus 1. That is 3. Okay. So now what we are doing here, let's see. Yeah, we have calculated this. So actually, in this case, yeah, in this case, we haven't increased. So in this case, we will take 2. So it will reach at here. So that's why it will return 1. So now, now what we will do here? Mm, don't do this. Yeah. So in this case, we have to reach. In this case, the middle node is this, and here you can say count. We are starting from 1. So initially, our I value is 1, and our pointer is at here. Now we will check is I value is equals to 3. No. So we increase the I value as well as move the pointer to the next node. Now we will again check if I value is same. No. So increase that by 1 and we move here. Now we again check is 3 is equal to 3. Yes. So in this case we will break, means we will stop here, right? If I is equals to middle, then we will break. After that we will return the 10. Okay. Yeah, it's working fine. So this is the one of the approach. Let's submit it. Let's submit it first and see working, giving the correct output for all the test cases or not. Yeah, so it is running fine. So if we talk about the time complexity, so basically you can say time complexity will be we are traversing once for the counting the node, or then the to reach the middle node we are traversing n by 2 node. So overall you can say that is a big of n time time complexity. Space complexity will be constant because we are not using any extra spaces here. Okay. Okay. So this is the first approach. Let's optimize it. Just uh, see the another approach how we can solve this. In in the last video, discussed. I solved the problem check the given list is palindrome or not, right? So in that solution, we have uses the function finding the middle of the list. So how we will find? This is the second approach. So what we will do? If suppose, let's understand the intuition first. So if suppose this is our starting point and this is our end point, okay. Here this is player one and this is player two. Okay. The speed of player one is one and speed of player two is two. Okay. Means in 1 second, player one will move 1 meter and player two move 2 meter in 1 second. So what happened? Let's say if this distance, if this distance is means the distance between these 2 points is 10 meter. Okay. So when player two first reach at two at first second in second in second step it will reach at 4, in third step it will reach at 6, and fourth step it will reach at 8, and fifth step it will reach at 10. Player 2. So it will take total 5 seconds to reach at 10. Now if we talk about this player 1, okay, so it uh, it travel only 1 meter in 1 second. So to reach at the end in 5 seconds. So in 5 seconds, where is one? Where will be one? Obviously, it will taking 1 second at traveling 1 meter, so it will add 5. After 5 seconds, it will add 5. So you can see 5 is nothing but middle of this distance. This 0 and this is 10. So when there are two player and one player is running uh, faster, twice faster than other player. So obviously, if it will take a let's say 10 minutes to reach at the end, so obviously the second player will take 5 minutes to reach at the middle. So we are using the same intuition here, right? So what we will do, we take a two pointer here, that is one is fast and one is slow. Okay. Fast will move two step at a time and slow will move one step at a time. Okay. So let's rub these things. Yeah, now it is okay. So what we will do, after 1 second, slower will be here and faster will be here. Faster will be here. In the next second, slower will here and faster will be here. Right? This is basically nothing but null. Means there is no node here. It is null. So in this case, you can see if we have even number of nodes, we know the middle node is that, and this time when the first will reach at the end, the second is at the middle of the node. Okay, so this is the first case when number of node is even. If we talk about when number of node is odd, so in this case what will happen, let's see. Yeah, it is there are 5 nodes here. So in this case, initially faster and slower both are at the starting point. After 1 second, slower will reach here and faster will reach here. Again, after 1 second, slower will reach here and faster will be here now. So when now if faster, basically faster, we know the faster travel 2 meter at a time, but there is only one distance left. There is only 1 meter left to reach at the end. So how, obviously faster will cannot move ahead. Faster will stop here. So in this case, slower is at here. And this is the middle of the middle of the list, and slower is pointing to the middle node. Okay. So we got the two condition here. Either either fast will reach at the end, or it will the 1 meter before at the end. Two condition. Then in this situation we have to stop because we cannot go ahead. Okay. So let's solve this question with this approach. So what we will do, we just take a two pointer, one fast and slow. Fast, and it is also it is in both of the fast and slow both at the first initially at the starting node, right? And after that we will say if faster will not reach at the end, and also faster, if we faster reach at the end, or faster is reached 1 meter before the end, then that case we have to stop. So when faster dot next is equals to null, in this case we will stop, otherwise we will move. So now what we will do, we just move slow pointer and as well as fast. So slow pointer move one step, only one step, but fast pointer move two step if we compare with slower, right? So in this case, at the end we see that when we reach faster at the end, slower is pointing to the middle of the node. So in this case, we will return the slower pointer. So we just return slow. Okay. So let's run and see. Next, something uh, typing mistake is there. Next. Okay. Yeah, it's working. Let's submit it. Okay. If we talk about the edge cases, when number of node is one, when number of node is one, let's say when number of node is one, then slow is here and faster is here. Then when we are checking this condition, right? So basically faster is at the one distance before the end. So in this case, this function means this will not execute and return the slow, and we know the slow is at the first node and this is the middle of the node. Okay, so it will run for all the test cases. Yeah, it is submitted. So these are the two methods to solve this question, middle of the list. Second one is optimal approach if you compare with first one. So here is the time complexity is only big of n m, and the space complexity is big of 1. Okay. So in this approach we need not to travel again. In only one traversal we get the middle of the list. So we will discuss the next question. I think I will discuss